It works like this. We start by writing down an alphabet. The most obvious would be the English alphabet of 26 letters, but Sanborn did something a bit different. He used what's known as a keyed alphabet. Basically, you select a keyword and move the letters of that word to the front of the alphabet. In Sanborn's case, he used the keyword kryptos, stemming from an ancient Greek word for hidden. Okay, so we move the K to the front, followed by the R, then the Y, P, T, O, and S. This keyed alphabet is then repeated underneath the first, but shifted one letter to the left. So it starts with the letter R, and the K is moved to the end. The next alphabet is shifted once more, so it starts with Y and ends with R. This process is repeated all the way down until we end up with 26 rows and 26 columns for each letter in the alphabet. So let's now use this table to encrypt a message. Something simple like, say, secret message. I know, I have a creative mind like the world has never seen. The first thing we need is another keyword. Let's say the keyword is hidden. Because secret message is longer than hidden, we simply repeat the keyword until it matches the length of the plaintext above. Once that's done, we're now ready to encrypt. The first letter of the plaintext is S, so we find the row that starts with S in the Vigenère table. The first letter of the keystream is H, so we find the column that starts with H. The letter at which this row and column intersect is the first letter of the ciphertext. In this case, that letter is Q. The second letter pair is E and I, so we find the row that starts with E and the column that starts with I, which intersect on the letter K, making K the second letter of the ciphertext. By repeating this process for all the letter pairs, we end up with a ciphertext that looks like this. That's it. That's how you encrypt a message using a Vigenère cipher. Likewise, by following these steps in reverse, you'd be able to decrypt the message. But as you can imagine, that only works if we know the keyword. Without that keyword, which functions very much like a password, it becomes significantly more difficult to crack the code.